Hello, this is Dr. Rhodey, and in this video I'm going to show how to use Excel 2010 to perform the calculations necessary for a chi-squared goodness of fit test. I'm going to do two types of examples. One, where the assumed distribution varies among the different categories, and another where the assumed distribution is evenly distributed among the different categories. In this particular example, a random group of seniors was selected from a university and asked about their plans for the following year. The school advising office claims that 60% of the students plan to work, 30% plan to continue in school, and 10% plan to take some time off. Is there evidence to reject this hypothesis at the alpha equal 0.05? So our null hypothesis here will be that the distribution of the student's plans follows this pattern as stated here. Our alternative hypothesis will be that it doesn't follow that pattern. Well, what we need to do is compute the chi-squared test statistic, and the chi-squared test statistic follows this formula. It looks at the observed counts and how it looks at the difference between that and what we would expect under the null hypothesis, and then it takes that value and squares it and looks at the ratio of that squared difference to the expected count. Then it adds up all those values and computes the chi-squared test statistic. From that, we compute a p-value, which will help us determine whether we have statistically significant evidence to reject or fail to reject the null hypothesis. So the first thing I want to do to apply this formula is determine the expected counts. Well, the first thing I do is figure out how many total people I surveyed. And in this case, I just need to total up that column. I'll hit the summation button here. And so I surveyed a total of 45. So if I surveyed 45 people and 60% of them plan to work, then I would expect that 0.6 times, using the asterisk for times, 45 would be the expected number of students that would say that they will work upon graduation. So in the next cell, I just want to do equals 30%, 0.3 times the total of 45. Enter. And for time off, 10% times 45. So these are my expected counts for each of these categories. Now, if you had a really large a large number of categories instead of just 3, you might cell reference this and anchor it and do a drag copy or something like that. But in my case, I just manually typed in these percentages. So I'm going to run the totals just to make sure that it adds up to 45. Now, even though these are counts, don't worry that some of these are decimals. These are theoretical values, so you actually carry all these. You don't round these. Now I need to compute the chi-squared test statistic. What I want to do is follow this formula using the cell references. So I'm going to do equals, parenthesis, and then I go over to my observed count, subtract my expected count, close parenthesis, use the caret key for exponential. I want to do squared, then the slash key for divide, click on expected, hit enter. So this is the contribution for this particular cell to the chi-squared test statistic. I drag copy that down, and then I want to total that up. So my chi-squared test statistic of 2 degrees of freedom, there are 3 categories, so I have 2 degrees of freedom. My chi-squared test statistic with 2 degrees of freedom is the 6.777, so on. The next step is to come up with the p-value. There are a couple ways to approach this, and I'll talk about them. To me, I think the quickest way is just to hit equals and type CHI, and you start getting your chi-squared commands here in this menu here. Now, I'm using 2010 version of Excel. If you're using 2007, it also knows those commands, so you can use those as well. But if I look here, I want to do chi-squared test. That's actually the easiest one to use, I think. So I can click on it and it'll actually tell me what it does. In this case, it says returns the test of independence, but we can actually use it here also for the goodness of fit. I'm going to double click on this, and now it tells me I need to do the actual range, comma, the expected range. So I go to my actual or observed and hit comma. And then I go to my expected, drag to that. Highlight that range. Do not include the totals and do not include the labels in this case. Shift, parenthesis, hit enter. So now I get my p-value, 0.03, so on. Well, 0.03 is less than 0.05, so I would reject the null hypothesis. So in this case, there is evidence in the data to suggest that the plans that students have after graduation is not the same as what the school advising office is claiming. Okay, what I want to do is show you the other ways you can get this p-value. One thing, instead of typing equals CHI, you can go up to this function icon, and it'll bring up this command screen where you can insert a function. Now mine's on statistical because I've been using statistical functions. You can also, if you're doing your homework, use most recently used if you're doing one type of problem over and over again, because then you'll find that in your most recently used category. But I just want to show you under statistical, what you would do is just arrow down. Here's my chi-squared functions. And so in here, I would find chi-squared test right here. And I could hit OK. And again, it tells you what it does. And in this case, you don't type it in. You use the command box here to highlight your ranges. So there's my expected, or they call it actual. Excuse me, my observed, I should say, and they call it actual. Then I highlight my expected. And notice it works kind of like a calculator. There's the number, but I'm going to hit OK. And so there's the same p-value. Just this cell is smaller, so it's rounded off. So that's another way to do that. You can either type equals, start typing chi-square, find the command, double click, go highlight the ranges, use commas to separate them, or you can use the function button up here and pull it up. Lastly, you may be asking, why did we bother to compute this test statistic when all we have to do is highlight the two ranges and get the p-value? Well, in the p-value method, one thing you want to do is disclose what your test statistic was. And this chi-square test does not produce the test statistic in its output. It only produces the p-value. So we have to compute this chi-square test statistic manually. One more thing is we could also use, instead of chi-squared test, I can use chi-dist right tail in the 2010 version, or just chi-dist in 2007. And notice it wants the right-tailed probability of the chi-squared distribution. I click enter. X, that would be my chi-squared test statistic. And then comma, degrees of freedom. Well, that's categories minus 1. I have 3 categories, so degrees of freedom is 2. I can close and hit enter. Notice you get the same number. So it's really your choice which way you want to do it. I think the chi-squared test is the easiest one to use. Okay, now let's do an example where you have a hypothesis that the data is evenly distributed among the different categories. In this case, a sociologist wants to determine whether there's a difference in the amount of time children aged 5 to 7 spend watching television each day. Let's check the following data for evidence that the number of minutes spent watching television is equally distributed throughout the week. Use alpha equal 0.01. So here again, we want to come in here and compute our expected counts so that we can get our chi-squared test statistic value. So I first need to know the total, because if it's evenly distributed each day, what I need to do is figure out, okay, of all the minutes that we've counted, how much would we expect each day if it was evenly distributed? Well, there's 7 days, so I would take 1197 and divide by 7. So I would expect 171 minutes each day if the null hypothesis is true, that they're evenly distributed. So I drag that down because it's the same in each one. I can check the total. Okay, now I compute the chi-squared test statistic. Equals, parenthesis, go to the number of minutes or the observed value, minus the expected value, close parenthesis, squared with the caret key, slash key for divide, expected. Hit enter. Now I want to drag copy that formula down, and there is my chi-squared values for each cell, and I want to sum it up to get the chi-squared test statistic. Now notice that the further away a value is from the expected value, the bigger the contribution of the chi-squared test statistic. And the larger the chi-squared test statistic, the further it will be in the right-hand tail, and therefore the probability that you're as extreme or more extreme than that value will be smaller and smaller as this chi-squared value gets bigger. And this, of course, small p-value would lead to a rejection of the null hypothesis. So let's see what we get here. Equal chi square test, double click. I want to highlight my observed data, or what they call actual range. Highlight my expected, not including the labels or the totals, just the cell values there. Close paren, enter. So here my p-value is 2.37 times 10 to the negative 19 power. Note, when it comes in this exponential form or scientific notation, this means times 10 to the negative 19th power. In other words, this is a decimal with 18 zeros, and then the number begins. Be careful not to write 2.372 as your p-value. P-values range between 0 and 1 because they're probabilities. They can never be bigger than 1. This is actually a very tiny number, so you could write p-value is approximately 0, or you could write 2.372 times 10 to the negative 19. So in this case, we would reject the null, and we have very strong evidence to suggest that the number of television that children age 5 to 7 spend watching each day is not